boys, let us find out the expression for electric field intensity. First of all, what is electric field intensity? The electric field intensity due to any source charge is defined as force experienced per unit test charge placed at that point. It is defined as force experienced per unit test charge placed at that point. So here I had taken a source charge due to which you have to find out electric field at this point. So if you place the test charge at this point, so force will be 1 upon 4 pi epsilon naught q naught by r square. So field, if you divide this force by test charge q naught, so field electric field intensity will you will obtain 1 upon 4 pi epsilon naught q by r square. Now regarding its unit, it is force upon charge, so Newton upon Coulomb. And regarding its dimension, force dimension is ml t raised to the power minus 2 upon charge is ampere into time. So it is ml t raised to the power minus 3 a raised to the power minus 1. Now let us find out expression for electric field intensity due to an electric dipole at its broadside on position. Here I taken two charges minus q plus q, so it is an electric dipole separated by distance 2l. So this line is perpendicular bisector line which is at a r distance from the center of the dipole. The electric field intensity due to minus q at this point is directed towards the negative charge, and electric field intensity due to plus q is directed from the away from the positive charge, and both having the same magnitude 1 upon 4 pi epsilon naught q by distance square, means the distance of observation points square. So if you resolve the electric field into components, E due to plus Q has two components, E due to plus Q cos theta in this direction, here it is shown, and E due to plus Q sin theta in the upward direction. Again E due to minus Q has two components, E due to minus Q cos theta in this direction and E due to minus Q sin theta in this direction. So these two components cancel out each other since theta is same and magnitude of electric field intensity is same. So the net electric field intensity will be the sum of these two components, E due to plus Q cos theta and E due to minus Q cos theta. So since the magnitude is same, so I had taken twice. So twice of E due to plus Q cos theta. So on substituting E due to plus Q or minus Q and cos theta from the triangle base upon hypotenuse, which will be L upon under root of R square plus L square. So on modifying the relation, we are having 1 upon 4 pi epsilon naught p upon r square plus l square raised to the power 3 by 2, where p is the electric dipole moment of the dipole, which is defined as product of magnitude of either of the charge and distance of separation between the two charges. And if you think about for a short dipole you have to neglect this term L, so it will be r square raised to the power 3 by 2, so 2 getting cancelled, so E equatorial will be 1 upon 4 pi epsilon naught p by r cube. So let us talk about expression for electric field intensity due to electric field dipole at end-on position or axial position. Here it is the dipole minus q plus q. The dipole moment is directed from negative charge to positive charge. 2l is the separation between the two charges, and this is the end-on position point where we had to find the electric field intensity. Due to positive charge, if the field is directed away, and due to negative charge, the field is directed towards. R is always taken from the center of the dipole, so this is R. So from positive charge the distance will be R minus L, since this much distance is 2L, and due to negative charge it will be R plus L, means up to center it is R, and if you add this much distance, this will be L. So E due to plus Q will be 1 upon 4 pi epsilon naught Q upon distance square. Distance of plus Q is R minus L, so r minus L the whole square, and E due to minus Q 1 upon 4 pi epsilon naught Q upon R plus L the whole square, since the distance is R plus L. If you compare the denominator, here the denominator is small, so this field is large, so E due to plus Q is greater than E due to minus Q. So net field in axial condition will be larger minus smaller, that will be net field will be directed in this direction, means away. So if you substitute E due to plus q and E due to minus q, and on simplifying we are having it is q upon 4 pi epsilon naught 4 rl upon r square minus l square raised to the r square minus l square the whole square. Again q into 2l is p. So E due to electric field intensity due to dipole at axial condition is 1 upon 4 pi epsilon naught 2 pr upon r square minus l square the whole square. Now if you consider about short dipole neglecting L in comparison to R, and it will be r raised to the power 4 in the denominator and cutting one r, so it is E axial is equal to 1 upon 4 pi epsilon naught 2p by r cube. So this is the electric field intensity regarding dipole. Thank you.